We have been hearing a lot lately about scientists discovering planets orbiting stars that are referred to as Earth-like planets. Now, planets considered to be Earth-like are said to be good candidates for supporting life. In fact, some scientists claim life would be inevitable on a seemingly Earth-like planet. Indeed, the late Carl Sagan asserted that because of the immense number of planets in the universe, many would have life on them. Just by the sheer numbers, well, this theory seems very plausible. But can life on a planet really begin so easily? Well, first of all, what is an Earth-like planet? And what requirements are necessary for the natural origin of life on that planet? Well, most scientists agree that the planet would have to be in what's called the habitable zone, a distance not too close to or too far from its home star. It would certainly have to have liquid water. It would also probably need to have some kind of a suitable atmosphere and temperatures that are conducive to life. Now, Earth, of course, meets not only these requirements, but many others that make it not only suitable, but truly an ideal planet for all types of life, both plant and animal. Well, with that, let me pose this challenging argument. The more we accept the idea of life being abundant throughout the universe, the harder it becomes to explain the natural origin of life on Earth. Now, let me say that again. The more we accept the idea of life being abundant throughout the universe, the harder it becomes to explain the natural origin of life on Earth. Well, since that sounds like an absurd contradiction, let me explain. The scientific assumption is this, that all life on Earth evolved beginning about 4 billion years ago from just one single cell. We can ask this question: over the course of 4 billion years, with the ideal conditions that exist on Earth, if all life did evolve from just one single cell, then how probable is it that life could begin on a planet with far less than ideal conditions? Say a planet that just meets the minimum requirement of having liquid water. Well, let's look at the Cambrian explosion and the theory of punctuated equilibrium. With the ecological factors and conditions being so ideal for the creation of so many new phyla during the Cambrian explosion, then the conditions should have also been ideal for new cells to originate. Otherwise, the assumption that a planet just needs to have liquid water for life to begin becomes very problematic. Do we see any evidence of different taxonomic ranks stemming from the creation of new cells occurring during the Cambrian explosion? It appears that all we really see is the evolution of new body plans during that era. And what about all of the pre-Cambrian eras? Liquid water and ideal conditions existed on Earth long before the Cambrian explosion. If life can begin so easily, then all life should not have originated from just one cell. New cells should have been popping up periodically prior to the Cambrian explosion. Is there any evidence of that? And then there's this. The conditions on Earth remained ideal after the Cambrian explosion. Yet we see 500 million years of post-Cambrian stasis, not just with new phyla, but also the creation of new life itself. Shouldn't new cells with subsequent evolutionary processes have populated the oceans throughout the past 500 million years? Well, all of this leads to another dilemma. Instead of just one single cell being responsible for all of life, if just a handful of new cells were created over the past 4 billion years, each creating an evolutionary tree of its own, the resulting population of plant and animal life on Earth would literally be unimaginable. Even the evolutionary concept of the survival of fittest cannot reconcile this dilemma. Well, from this discussion we can draw the following conclusion. Earth is the absolute ideal planet for life. If all life on Earth did originate from just one single cell some 4 billion years ago, and no other new cells were created during all that time, then the likelihood for life beginning on another planet just because it's in the habitable zone and has liquid water on it is virtually nil. The reality is there is a huge stumbling block when considering the origin of life on other planets.